Robots are dangerous machines. They can put people at risk, for example by colliding with them or by clamping the user's limbs. In this video we show how EAROS helps to keep a better eye on these risks and to prevent software development errors that can lead to dangerous situations. To make a robot safer, we try to detect the risks mentioned with the help of sensors that safely monitor a collision area, for example. In order to stop the robot safely, additional software is needed in which the stopping process is clearly defined. Of course, one tries to develop this software in such a way that dangerous situations are safely managed. But what happens if the risks arise in the software that you have written yourself? The software could be faulty. What if the sensor functions incorrectly or the system does not switch off reliably? To deal with these dangers, EAROS offers a safety system. This is not designed to replace reliable sensors or safety-approved actuators, but it is designed to help the programmer avoid making mistakes when designing the safety functions of the systems. Once defined properly, it gives the developer freedom to try out new algorithms without the fear of getting into dangerous situations. The safety system controls all interaction with the hardware abstraction layer and ensures that the actuating values of the control system and the sequencer are applied to the hardware in such a way that safe operation is guaranteed. At the same time, it also provides information to the control system and the sequencer about the current safety status of the robot. The safety system therefore monitors critical hardware inputs such as emergency buttons or safety sensors and regularly sets the safety critical output such as brakes and motor current to ensure safe operations of the robot. If the situation becomes less safe, the robot may have its movements restricted to avoid damaging nearby people, materials, or itself. Of course, this depends on the current state the robot is in. If it is switched off, it naturally causes much less danger than if it is moving around. For this reason, the state of the robot is modeled in so-called safety levels. Safety levels define exactly which state the robot is in. Such levels can be, for example, initializing, homing, or running, or as shown here, system on and system off. The order of the safety level numbering corresponds to the potential damage in case of an error. System on is more dangerous than system off, which is why system on has a safety level of 3 and system on only 0. But what exactly happens when a transition between the safety levels takes place? When the robot is switched on, it may take some time until the relay is energized and the robot is ready for operation. During this time, the safety level is neither system on nor system off, but something in between. In EAROS, these are called hidden states because they exist but are often not modeled. However, a correct implementation in EAROS requires that these hidden states are modeled so that the safety system functions reliable and error-free. Therefore, we insert so-called transition states, which are usually written with ing at the end. In our case, the safety level changes first to switching on and then to system on when the unit is switched on, and to switching off and then to system off when it is switched off. A change of the safety level can only be caused by an event, and events are exclusively received and handled by the safety system. Such a change can happen only if the specific event was registered for the current level. If an event is called that is not registered and for which no reaction is provided in the current safety level, it is simply ignored. An event can be triggered by the safety system itself. In this case, we call the event private. On the other hand, it can also be triggered by the control system or the sequencer. In this case, we call it a public event. In our example, the sequencer triggers the event do system on, instructing the robot to switch on. This event is public and is only registered in level systems off. If the safety level of the robot is in the safety level system off, this triggers a transition from the safety level system off to switching on. In this transient level, the safety system waits until the robot controller has started up and triggers the private event switched on, which leads to a level change to system on. When switching off, the same happens in reverse order. Safety relevant inputs and outputs should be monitored directly by the safety system. The following actions could be performed on an input. We could ignore the input, which is marked by X. We can check if an input matches a given value, or we can check if an input is in a given range between a minimum and a maximum. An output can react by be set to a certain value, by be left an output on its current value, which is already there, or we can toggle the output. The toggle output is very important if we want to realize a watchdog signal. The action taken depends on the current level. Let us look at a brief summary of the safety levels and their properties. A safety level has a unique ID number, has a unique name, defines the state of all critical outputs, defines conditions for the critical inputs which are checked periodically by an inspection task, can accept certain events, and can cause events. Software-wise, the safety system consists of two classes, the safety system and the safety properties. The safety system reads and checks critical inputs, executes levels actions, and sets critical outputs. Safety properties is the place to define and declare the safety levels, safety events, critical inputs and output, critical input and output actions, level actions, and entry level. The developer only specifies the safety properties. The safety system class is already complete. Thank you for your interest, and if you have any questions, we will be happy to answer them in the forum. As a next step, you can watch the video with implementation guidelines for the EAROS safety system. We wish you good luck with your first implementation of an EAROS safety system and look forward to see you again in the next video.